But we already know that there are two types of beta emissions. One is beta minus and beta plus emissions. Beta minus is an electron, and beta plus is a positron. An electron emits out of the nucleus when a neutron splits up into a proton and an electron. An electron emits out. And hence, since you have one excess proton over there, so the atomic number increases by 1. And you have one less neutron, so of course the number of neutrons will reduce by 1, but the total number of nucleons in the nucleus will remain same because only one neutron has now become a proton. And then a beta minus emission takes place, and there's going to be another particle, a very, very light particle that forms alongside, and that's called antineutrino, or also sometimes called electron antineutrino. But you have to look at this in one another way, and that is that when a neutron becomes a proton and emits electron and antineutrino, if you look at the composition of the neutron and proton, a neutron has 1 up and 2 down quarks, and a proton has 2 up and 1 down quarks. So you can also interpret this as a change in flavor of one of the quarks. A 1 down quark turns into an up quark. And when a down quark turns into an up quark, it emits a W minus boson, which holds an electron and antineutrino together for a very small fraction of a second. And then that splits up into a beta negative and an electron antineutrino, which is why earlier on I was telling you that W minus boson is an exchange particle which is involved in weak nuclear forces. And a weak nuclear force is a force that holds beta and neutrino together for a very small fraction of a second before they split up and they get emitted from the nucleus. Okay, and very similarly, when a beta plus emission takes place, you know that a proton splits up into a neutron and positron. And since a proton is being reduced, the atomic number would reduce by 1, and a proton has become a neutron, so the mass number would remain the same. A beta plus emission and a neutrino would be emitted. So that's something you do know. But when you look at the configuration, so you would say a proton becomes a neutron, emits a positron and electron neutrino. But this can be interpreted in one another way, and that is that when proton turns into a neutron, one of the quarks changes its flavor. That is, it was previously an up quark and it becomes a down quark. And when an up quark becomes a down quark, it emits a boson that's a W plus boson, which is holding a positron and electron neutrino together for a split second. And then they break apart and they get emitted from the nucleus. So W plus and W minus boson are bosons which are involved in weak nuclear forces. And what is a weak nuclear force? A weak nuclear force is a force that holds, of course, the weak nuclear force, so it would be affecting the leptons, and it would be holding the 2 leptons together. In case of beta minus emission, it would be holding an electron and an antineutrino together, a W minus boson. And in case of a beta plus emission, a W plus boson would be holding the positron and an electron neutrino together. And then the other thing that we did make a long list of what's conserved and what's not conserved in a nuclear reaction. So you also need to acknowledge the fact that the lepton number is also, you can always say that or state that a lepton number would be conserved in so a lepton number is also conserved in a nuclear reaction. If you would look at it very closely, you would find electron in the fundamental particle table, but there is no antineutrino because it's an antiparticle of neutrino. So a particle would have a lepton number of 1, and an antiparticle would have a lepton number of -1. So the total lepton number stays 0. Whereas a neutrino has a lepton number of 1, whereas beta plus is not part of the fundamental particle table. It's an antiparticle of beta minus. So when beta plus emission takes place, so this is a lepton number of -1, and this is a lepton number of 1. So then again, the total lepton number would stay 0. And again, you could say that a lepton number in any nuclear reaction, and in this specifically, the lepton number is being conserved.